again. All right. So while I did solve the first one very analytically, we can use our trigonometry theorem with right triangles to derive our formulas for converting from polar coordinates to rectangular coordinates. And we can take the general polar coordinate, where you have a distance from the origin to the point R, an angle theta, and then horizontal and vertical components x and y, that using trigonometry, x is equal to r times the cosine of theta, and y is equal to r times the sine of theta. And these are polar conversions, polar to rectangular conversions that we need to memorize. So we need to memorize these. Okay? Alright. With that being said, let's apply our polar to rectangular conversion formulas to find out our answer. X is equal to r times the cosine of theta. So when r is 1/4 and theta is pi over 2, x is equal to 1/4 times the cosine of pi over 2. Y is equal to 1/4 times the sine of pi over 2. From our unit circle, x is going to be equal to 1/4 times the cosine of pi over 2 is 0, and the sine of pi over 2 is 1. So x is equal to 1/4 times 0. Y is equal to 1/4 times 1. So our rectangular coordinates are going to be 0. 1/4 times 0 is 0. 1/4 times 1 is 1/4. So those are our x and y coordinates for problem 2. Now, 1 and 2 used our theta value in radians. All right, 3 and 4 use, or 3 and 4 are going to use our angle value in degrees. And so this one we might need to bring out our calculator. So with 3, our polar value is going to be, define our rectangular coordinates. X is going to be equal to 5 times the cosine of 240 degrees, and y is going to be equal to 5 times the sine of 240 degrees. All right? And this is where we can break out our calculator. We can go to degree mode because we're in degrees. We can find 5 times the cosine of 240 degrees, which is going to be negative 2.5. All right, and then 5 times the sine of 240 degrees. Which is going to be negative 4.33. So we're going to have an x value. Our x rectangular value is going to be negative 2.5 for our horizontal component. Our vertical component is going to be negative 4.33, which means our rectangular coordinates are going to be negative 2.5, negative 4.33. For 4, we were just plugging and chugging in the same manner. X is going to be equal to 4 times the cosine of 150 degrees. Y is going to be equal to 4 times the sine of 150 degrees. So x is going to be equal to 4 times the cosine of 150 degrees. y is going to be 4 times the sine of 150 degrees. So we plug these into a calculator, and we're going to get rectangular coordinates of negative 3.46, positive 2. So we plug these values into the calculator, and we get rectangular coordinates negative 3.46, positive 2. Let's box our answers. So so we're following best practices here. All right. 5 is going to use radians, and 6 is going to use degrees. Okay. So 5 is going to do 11 and 11 pi over 6. All right. So our x value is going to be, so our polar coordinates are going to be 11. Our x value is going to be equal to 11 times the cosine of 11 pi over 6. And our y value is going to be 11 times the sine of 11 pi over 6. All right? And from the unit circle, all right, does anybody know what the cosine of 11 pi over 6 is? Should be negative root 3 over 2. Right? So you have 11. Sorry, it should be positive root 3 over 2. My fault. 11 times positive root 3 over 2. My fault. And 11 times the sine of 11 pi over 6 should be 11 times negative 1/2. So x is equal to 11 times root 3 over 2. Y is equal to 11 times the sine of 11 pi over 6 should be 11 negative 1/2. So we should have rectangular coordinates of 11 root 3 over 2 as our x coordinate, and negative 11 halves as our y coordinate. All right, so that's 5. For 6, we're going to have 3 halves and 630, so we can definitely plug this to our calculator. Our x value coordinate is 3 halves times the cosine of 630. Our y value is going to be 3 halves times the sine of 630. All right. And then we take our calculator. Our x value is going to be 1.5 times the cosine of mode degree. So make sure we're in the right degree, 630 degrees. And our y value is going to be 1.5 times the sine of 630 degrees. So that's going to be 0, negative 1.5. So we have an x value of 0 and a y value of negative 1.5. All right. For 7, we're going to do the last two before we move on to the next video. For 7, we have 7, 1, 3, 2. All right. So we are going to have an x value of 7 times the cosine of 132. Our y value of 7 times the sine of 132. And then we're going to have we can do 7 times the cosine of 132 for our x-coordinate, 7 times the sine of 132 for our y-coordinate. So we're going to have polar coordinates of negative 4.68, positive 5.2. So we're going to have negative 4.68, positive 5.2. Remember, I guess it's best practice to always indicate that what we're plugging into our calculator. Make sure we put in our degree sign. Alright. Our last problem is going to be negative 1 times pi over 9. This one's going to be a little bit tricky because pi over 9 isn't a unit circle value that we have to memorize, but that's okay. We can still find it by knowing that x is equal to negative 1 times the cosine of pi over 9 radians, and y is equal to negative 1 times the sine of pi over 9 radians. And then at that point, we can go to our calculator. Because our angle is in radians, we can switch to radian mode. And then plugging it into the calculator, we can put in negative 1 times the cosine of, and then let's put a second parentheses, pi divided by 9, close the parentheses, and then we'll get negative 0.9396. So let's just do negative 0.94. That's a good. So x is equal to negative 0.94, and we plug this into the calculator in radian mode. Alright, and then we are also going to get our y value. Our y value is going to be negative 1 times the sine of pi over 9, which is going to be negative 0.34. So x is going to be negative 0.94, y is going to be equal to negative 0.34. So we're going to get rectangular coordinates of negative 0.94 and negative 0.34. And that is our solution. And that is our video for converting from polar coordinates to rectangular coordinates.